Dear students, greetings from Dr. T. Sendil Murugan, Associate Professor and Head, Department of Information Technology, Kakatiya Institute of Technology and Science, Warangal. In this video lecture, we are going to discuss about Deque, DQ. Okay, so we can call DQ. This is one type of the Q. We can call like Deque also, DECK. So it is actually spelling is DEQUE. It is not UE, only Deque. We can call Deque or DQ also. So in this operation, it is a special type of Q. So that we are going to discuss about DQ in this video lecture. So dear students, this is week 7, lecture 2, classroom topic 20. We are going to discuss about DQ. So DQ or Deque, we can call Deque or DQ. Okay, so before starting our lecture, we must be discuss about lecture outcome. So for this particular lecture, after completion of this lecture, students will be able to develop a C program to demonstrate the DQ data structure with its operation using circular cube, and as well as the student can apply DQ concept in real-time applications also. Wherever it is required is there the students will be able to use DQ concept. So what is DQ? So now we can pronounce like Deque or DQ, I already told. So here we can say that head tail linked list. We are saying that head tail linked list because the elements can be added or removed from either both front side or back side. Okay, that you have to remind it. So here, however, no element can be added and deleted from the middle. Okay, so if Q is there means here we can say this is, we know the two pointer we are using, front side and rear side. Front pointer we are using for delete operation, and Q rear point is used to delete insert operation. We can using this two pointer, but in this Deque we are using two different pointer. The pointer may be called like left and right. Okay, two pointer we are going to use. Left pointer is pointing to where the elements start in the left side, and right pointer is pointing to where the elements are available in the right side. Okay, so in case we are deleting the element means left pointer will move to right side, right pointer it is, we can implement the circular cube. Again, Deque we are using the circular linked list, or circular cube. So using these two concepts, we can implement the Deque, this concept. Clear? So the thing is that we are using two pointer. These two pointers are used to performing the operation in the Deque. So there are two variants of double-ended queue. So this we are saying this double-ended queue also. Deque may be called like double-ended queue. Don't forget, this word is important. Okay, head and tail linked list. Here double-ended queue. So when we are using the queue concept, we are saying that double-ended queue. So in this there is two variants. One variant is input restricted Deque. Another one is output restricted Deque. Input restricted means insert operation at only one. Okay, only at the one of the end, but we can perform delete operation in both the ends. Okay, so here insert is only one end. So hence we will share the PPT. So we have two variants of Deque. In that, one is input restricted Deque, another one is output restricted Deque. Input restricted Deque means we insert element in one side, but we can delete the both side. So it is just opposite for output restricted. Okay, delete we will perform at only one end, but insert we can perform in both the ends. Okay, so this is output restricted Deque. We have two variants. So we, with the concept, we have to implement the Deque using C program. So one is input variant, another one is output based variant. So two variants, two different function we are written. So if we want to insert from left side, this function we will use. Insert from right side, we will use this function. Insert, delete element in the left side, delete element into the right side. So 6 functions we are used. Apart from the display function also we are used. First we have to choose what we are going to do. We are going to use input Deque or output Deque. From that we are using this option, input Deque or output Deque. Using this option we are taking. So after selecting this, if in case you are chosen input Deque, it will ask where only input Deque means you can insert element into right position, only right position, but you can delete element from both the ends. Okay, so you can just remember that insert element at right side when we are using input Deque, only one end, but we can perform both the end for delete operation. Okay, so again after choosing this operation, insert operation and delete operation, we can call that function directly according to option you are given here. This option it will work with this switch cases. Okay, so in case you are chosen output Deque means you can insert both the side, left side and right side, but you can delete from only left side. So this is output restricted. After getting that, you have to give the option insert right side, insert left side, and delete left side, not delete right side. Delete right side is not possible in output restricted queue. Okay. So finally, display operation. So insert right side, what we have to check? The queue is there. Okay. So here the left pointer is pointing here. The right pointer is pointing here. Okay, example. You want to insert right side. What you have to check first initially? So the queue is full or not, you have to check. Full means left pointer pointing to 0 location, right pointer pointing to maximum location. So here it is pointing 0 location, left side, right side pointing to maximum minus 1 location. The queue is full. Okay, you are unable to insert the element. Or in case the left pointer is moving this side, right pointer is moving this side. Okay, so that condition left is greater than, sorry, equal to right plus 1. So some value it is greater. In case it is greater means it is not able to insert the element. That means it is pointing to here. Left pointer is pointing here, right pointer is pointing here. Okay, from this elements are there, here also element is there. In between no gap, no space. So we are unable to insert the element. So if we both the condition, we can say this is overflow. Otherwise, what we have to check? The left pointer is pointing. There we are inserting right side. If in case if the left pointer is pointing to -1 only, that means we have to change first location. Already we are using front and rear equal to 0. No, same condition you have to use. In case the queue is empty means first step you have to change, assign the value 0 for both the pointer. Then you have to insert the element. So if not, this is also not, it is not empty. Then again we have to check right equal to max -1. Right pointer is pointing here. Okay, so right pointer is pointing max -1. That we are checking. If in case if it is there means what we have to do? So right pointer. So after that not -1. So it will pointing to the 0th location again. Circular queue no. So again it will comes to 0th location. That's why we are using right equal to 0. So in case if it is not empty here, it is not empty, it is not last location means simply we can write right equal to right plus 1. Okay. So simply we can write this value. So DQ value of right side. Insert left side. Okay. So what we have to insert, how we can insert? Again, we have to check it is overflow or not. It is crossed that value or not. If both the condition true, overflow. It is common to all the queue. Okay, if you circular queue we are using means this condition, if you are using linear queue means this condition. Okay, So we will print overflow. Otherwise, we can check again. Left pointer is -1 means initial stage. We have to change the 0 value. Then we have to assign the value. If in case left equal to 0, left equal to 0 means only one element is there. Okay. If left equal to 0 means we have to check it is equal means then left equal to max -1. We will change it to next position. Okay. So example, what we are doing, insert the element. Where we are inserting, left pointer is pointing this side. Okay. If you want to insert, here already is there. So there is no space here. Then what it will do? It will goes to here. So this is left side we are inserting. Left side means again left equal to 0 means then left will be shifted to max -1. Okay, that's why they are written this statement. So in case this condition is not there, then means so some values are there. In case it is pointing here means it will pointing to here. It will insert here. That's why left equal to left -1. Okay. So dq of left value we can perform this value. Whatever value is there, just we will do this. Actually, this function for NQ operation. Yes. So delete operation, what we will perform again? So the delete operation left equal to -1. So that empty, Q is empty or not, we have to check. If left pointer pointing to -1 means it is no values are there. And left equal to right means only one element is there. After deleting, Q will be empty. That's why we are fixing -1. So if it is not one element, it is not empty. Then we have to check left equal to max -1. Max -1 means in the queue right side, last only one element is there. Then we have to change it to 0th location. Then else all three condition fails. Again, we have to change it to left equal to left +1. Okay. Delete the right side. Again, same. We have to check left equal to -1 means underflow. Again, left equal to right means first element. So after deleting one element, both will be pointing to the null element. If not, we have to check right equal to 0. If right equal to 0 means, again, right pointer pointing to 0 means right side we have to insert. So right equal to max -1 we will write. Right equal to right -1. So this is the right delete right operation over. We are discussed about insert left, insert right, delete left, delete right. Okay, finally display operation. How we perform the circular queue, same thing. First we have to check it is -1 means simply you can print empty. Otherwise, in case the elements of the queues are so front pointer and is greater than the rear value means up to this point you can print it. Okay, you can call this Deque function for display the values. Print plus plus. You can simply front value will be printed up to rear pointer. So both the condition fails, then it will check front is less than or equal to max -1. Max -1 it will check. If it is max -1 means up to from the front pointer it will increment up to max -1. Okay. Then they are changing to front equal to 0. So in case if it is there, then again it will after reaching the max -1 again it will print it up to this condition satisfies. It will print the value front plus plus. So this is sample output. I hope you understood the concept of this. We are in the end of the lecture. So what is Deque? What are the pointers we are used? We are used left and right pointers. We have four operations: insert left, insert right, delete left, delete right. How we are performing? When we are performing? What are the two variants of the Deque? Output restricted, input restricted Deques we are discussed. Then the conditions, what are the conditions should be there? Is empty, is full. So that we are checked. If it is empty means underflow we are written. If full means overflow we are written. Otherwise we performed the Deque operation. Finally we are discussed about Deque using C programs also. So I hope you enjoyed. Now you are able to use all the operations on Deque and write the applications of Deque. Wherever the Deque concept is used, there you have to identify and write it here. Then there, how you are performing these operations, for that you have to write the program. Okay. So now we are in end of this lecture. Having completed the discussion on Deque concept, now students should be able to develop a C program to demonstrate the DQ data structure with its operation using circular queue. So if you have any doubt, you refer chapter 8.4.2 circular queue concept with Deque. Okay, these two you can refer in Rima Tareja text, reference book. Okay, further doubt will come with the doubt. We will discuss in the classroom discussion. Thank you very much for listening, okay, without interruption. Thank you all.